Okay, so we're back to kind of wrap up thinking about land cover in the Pleasant Creek watershed and how we can see how it's changed over the time period between 2006 and 2019. And so I just want to point out that I've already done something here, which uh, you need to do to kind of do this analysis. So if you go to Canvas, I made an announcement where you can download the 2019 and 2006 area of the National Land Cover data set for the region that we're studying. But you're going to have to go and do some geoprocessing by clip raster, basically. And so you would, you know, you could type in clip raster, you go in, you input your raster, like the one that I've got here, and then you are going to want to clip it to the area of the watershed, right? So PC watershed. Remember that you need to use the input features for clipping geometry so that when you clip it, it has that shape rather than some square shape like you see here. So I've already done that, so I'm not going to do that again. And so you can see my 2019 data on top of the 2006 data. And if I click them off and on and I've zoomed into this one area here, you can see some changes have occurred. And so some hay and pasture have changed to cultivated crops and vice versa. Some things along the road were interpreted differently by the remote sensing. They added some hay and crops or removed it, I guess, over here. If we look in the higher part of the watershed, you can see some changes along the roads and also in the forest a little bit. More forested, less forested, or different types of forest. So what I'm asking you to do in the analysis is to think about how you can quantify this, how much area of the watershed has changed, and what did it change to? And I ask you, does this make it likely that we're going to see like a different amount of erosion on the landscape or not, just based upon what you learned from the readings? And so the way that I would approach this is to use raster calculator. And so we go to raster calculator, which is under map algebra. And what I've got here is my two clipped areas for Pleasant Creek 2019 and 2006. And we can use the operator of conditional. So it's like we're going to set a condition. And so what we're going to set is where they're not equal to each other, where change has occurred. So I enter one data set, it puts a comma. After the comma is like what you want it to return. Before the comma is the condition. So the way, if you just type that, it's like it'll give me something wherever that 2006 land cover data exists. So we need to add more to this condition. We can do operators like multiplication, addition, subtraction, is defined as equal, greater than, less than. But there's also this exclamation equal, that means not equal to. So I'm going to double click on that. And so, and it's not equal to 2019. Okay. So basically I'm saying they're not equal to each other. And then I'm going to return a value of, I guess, 1. They're different. Okay. I could add another comma and say, get a value where they're the same, and that would be 0. Yeah, why don't we try that? So it'll give me 1 where they're different, 0 where they're not. And so then we're going to do, we'll just call this land cover difference. Okay, we'll run that. So there we go, 0 and 1. And so you can see that there's a lot of 0 and not a lot of 1. Okay, so that's cool. So we can, if you wanted to know the area of change, you can open up the attribute table. We can see how many pixels are 1 versus 0. You could get the area pretty quickly, actually, if you do a conversion tools thing and basically go from raster to polygon. So we put that Landcover difference in there and the field being value. And we'll call this now National Landcover data set 2019-2006 change. Okay, run. Okay, now that must have appeared up higher. So it's showing as like a couple of colors, which it should. Let's open the attribute table of that. Okay, so we can see I didn't do this right. Why? Because I didn't create multi-part features. Let's close that. Let's do create multi-part features. Let's remove this and overwrite it. If you create multi-part features, it lumps them all together. So if we open the attribute table up for that now, you'll see that the area is calculated in there for the different grid code values. And I believe that's in square meters, which is my map units. So it's, you have to maybe convert that to square kilometers or something else. You can also add a field and can make it a float, and we can call it area or acres if you wanted, or square miles, whatever it is. Okay, so save that. Go back, and you can right click, calculate geometry, and we want to figure out the area in, I said square miles, right? There we go. And use the current map. Okay, run. So 113 square miles didn't change. 0.24 square miles did change land cover in that time period. So that's a great way to figure out how much change there was. If you want to know what it changed to, that's another thing. So I'm going to move this change detection thing next to the difference one so we can kind of see them next to each other. But we're going to then go back to raster calculator. So I'll scroll down here. And I'm going to show you that we can then highlight what has happened. So mine is called land cover difference. And I'm going to go back to that conditional statement. Say conditional where land cover difference is equal to 1. So we're going to go this double equal sign, and we'll put the value 1 in here. Then I'm going to return I want to see what it changed to. And so then I want it to be equal to the 2019 data. Okay. And then I'll say that this raster that's going to be output is, we'll call it new land cover 2019. Okay. So we can run that. And it should just give us the Landcover values on top of those changed pixels. So to prove that, I'll turn these off for a second here. Turn all these off. Okay, so there's our new Landcover 2019. So right here, this is a new pixel value is 42. So the color coding is not the same, right? So the colors here are not quite mapping to what we were looking at before. And we don't have that color map here, unfortunately. So that's a good thing to note. But there's something we can do with that. So this has an attribute table associated with it. Okay. And also there's counts, right? So these have values. So we can join basically the 29. So the join field can be value, and we can join the original Landcover data from National Landcover Data 2019. And watch this. We'll append all those attributes, open water, etc. And so that's preserved in this pixel values here. So that's really cool because, then we can say, also in the original data, we can see how many pixels there were in 2019 like that. Can I edit the count? Probably not. Let's see. Go into fields. Not yet. Okay, so I'm going to do another. So what I've done is I've done a table join where I joined the new Landcover, which was object ID, value, and count, to the values of the original 2019 Landcover data. So it tells us, how many, what the difference is right now. Water, got 11 new pixels of water out of a total of 79. And that's from 2019. We could also join the 2006 table. So you have to keep your head straight in this one, but check it out. So let's add another table join. And then this time, so it's also going to be on value, but the new table we'll join is 2006. And it needs to be the one that's clipped to Pleasant Creek. And we'll keep all features again. And we should get basically a repeat. And so in 2006, there were 54 open water pixels. And in 2019, there were 79, value of 11 open water pixels. And then if we look at the difference, we can see there were 25 areas that became water in 2019 that were not water in 2006. But if we do the math on that, 79 minus 54, is that exactly 25? It is. I was thinking it might not be because you could have a mix of changes, but it does add up in this case. And so this is pretty cool because if we can export this, we can do some ratios of those to figure out what the percent change of these different values are. And so what I'm going to do is this. I'm going to I'm going to now go to the join and relates, and then let's see if we can, wonder if we can export this. I think the issue here is the pixel type is mixed. That's not going to work very well for us. So basically what you're going to want to do probably is export this table and do some of the math on that. So we're going to export the table, and maybe you could put it in the geodatabase, but you don't have to. And so, yeah, we'll put it in that location, and we'll just output it as pixel change or something like that. Okay, so I'm going to see if that shows up as a table. So it does, in this case, show up as a DBF table. And oh, here it is as well. So if I open that table, let's see what it looks like. Okay, so we've got these things in the table. And so presumably we could also like add fields and do math in here, um, do some plots and things to show how these values have changed. So water has become bigger. What else has changed, right? So this table will give you everything you need to go after that. It is potentially possible that you could also do conversion tools. I wonder if that would work pretty well. So we could go to Polygon from this new one, create multi-part features, and we call this Raster T new Landcover. Okay, let's just let it run like that. See what that looks like. If we open the attribute table on there, it didn't spit out all of the table information, unfortunately, but it did give us the area of the different grid codes in square meters, which is somewhat helpful. You could recolor code it there, but it is an interpolation. You can see it's not the pixels itself, so that's a little bit sketchy. A better way might be just to assume the pixel size and do a multiplication by count to get areas there. All right, so hopefully that gets you started with assessing land cover change using raster calculator and joining tables um, inside of rasters. And so maybe that's a good lesson too, that rasters have many values and bands potentially, just like shapefiles. Okay, so we'll stop it there.